So hi everybody and good afternoon. I'm excited to be here with Meirav, the CTO of Campus IL, and Rui Shilo, the Chief Architect from Midlink. My name is Avishai. I lead the business dev at Campus IL, and we are really excited to present to you today a cool feature called Blender for empowering teachers in blended learning scenarios, which happened to be very important as we realized during the world pandemic. And the first Campus IL is a joint venture of the government, of the Israeli government, and the Council for Higher Education. We have dozens of partners, leading universities, governmental units, and so far that's the numbers, and you can imagine the growth while the last 2 years. We have over 500,000 learners and 300 courses and 200 more in the oven, in the making, what they call. And we're targeting really wide audiences. As I said before, it's like puzzles from the age of 3 to 120. So we're targeting really wide audiences. And that's the vision that guides us through the 4 and 5 years. I'm glad that Eran Raviv here is a former CEO of Campus IL with us. And our vision is promoting the general, professional, and academic education in Israel in order to reduce social inequalities and accelerate economic growth. So the vision is great. I once been told that it's clever to add a question mark to a vision, to keep the tense, to keep the vision dynamic. And I don't know if some of you will identify with this saying. We know that the completion rate is very poor. Also in the words of diet, or I promise myself I go to start with yoga or mindfulness or gym or running or whatever. But we know that the few who really succeed are the ones who enroll to guided groups, to local small guided groups. And that's make the whole picture different, the completion rate, the satisfaction, and it's easier to achieve goals. I don't know which of you went to the session before of Eran. He just presented that this is the difference between like 3-4% completion rate of the MOOC and 95% of completion rate when you do it in a guided group. So it's a whole different world, and this is the main key secret for everything. And I can truly see the similarity between the two worlds. And like the sports facilities you have in the park, that people like me that don't like the indoor experience of gym and like to do it in the outdoor, it's great for them. And there are groups that comes with a coach or with a guide and helps them to reach their goals. I see a great similarity to the world of MOOC. And 4 years ago, the Israeli Minister of Education arose a need. They wanted to open thousands of classes guided by a local teacher for high school, for preparation for matriculation exams, courses on Open edX we have. And they asked us to open thousands of classes. And everything was great, but the problem is that all the data is in the hands of the master course team. So the local teacher is literally blind. So everything is great on week 1. I come to a class, I step into a class and I say, hey, I brought you a course from Stanford or from a university, Tel Aviv University, and all the parents are happy and everyone excited. That's on week 1. But on week 4, on week 5, I enter the class as a teacher and I am blind. I don't know to tell you that you need help and I'll help you. Well done, you did a great job on chapter 6. And I feel in an unsafe zone. And as a teacher, it's horrible, and I'm an educator, it's horrible experience. And that's the main reason I realized that in the last decade that teachers and lecturers just kick out MOOCs out of their class. This is the main reason. Week 1 is great. Week 2, 3 is horrible. And what we did is we followed Davidson Next College in North Carolina and MITx, woo, where this cool feature of CCX was developed. And CCX allows you all these things. It's recommended to be up to 200 students, and you can track the grades and the progress. And a main feature is that a local teacher can adjust the exposure dates of the course. So if I want, I will start this CCX on January, and if Sergey, you want, you will start in April, and it's tailor-made for the teacher, and everything was great, and they opened the champagne and everything, but none of the 1,000 and more teachers that did it in the last years used the ability that the system allows them, the edX allows them to download data. Because the insight was designed for a MOOC. We have this joke that in the insight you have the percentage of the female and male. So I, as a teacher, I teach a class and they tell me that 60% of my students are female. I know you for 2 years. I don't need to see it on the dashboard. So it's designed for a massive amount of students, whereas I have 35 students in my class. So they didn't download the CSV and then convert to Excel. It was horrible. And I myself, I got thousands of curses from this precious audience. So we came with really a dream to invent something called Blender, which is like a product for a teacher just before the face-to-face meeting with his class. Nowadays, maybe it's a Zoom session or whatever. After they went to the grazing in the field of online learning, and I don't know what they did there in chapter 4, and then we have a meeting on Thursday at 4 o'clock, a face-to-face meeting. And we imagine something you have in the theater, you have a prompter, a whisperer, that tells you, go to this student, help this student, divide the class into 4 groups and help them. And we developed it in cooperation with the Israeli Minister of Education and Mindcet, which is an EdTech hub in Israel. And I can tell you, and I will sum it at the end, that there's a great value for the local teacher, which in the eyes of edX and to you is a great distributor. One teacher brings 200 students that their completion rate is 95%. And we just redefined this profession of a teacher and enabled this move. And now I'm glad to pass the microphone to my colleague Meirav.
Thanks. So let's see how it really works. We based on open edX infrastructure, which means we took the CSV files and we add a lot of components that's regarding to the Blender. All the CSV files are located in a 3S bucket, while the Blender is listening to this and just pulling out all the CSV files after and analyze this data and show it by a UI's interface. The registration process goes like this. First of all, we need the teachers to registration to the form, which means we're using Google Forms. The teachers need to say, okay, which class I want, what's the name of it, how many students, and etc. Afterwards, we're using the create the class of CCX, as Avishai mentions, which means we need to enrollment all our support group, enrollment all the students of the 2,002 students, and create a class. And eventually, we're using the periodic task, as Paul from OpenCraft showed us like 2 days ago, with the Django. Actually, to tell you the truth, this is a pain point because we need to schedule it and every 24 hours, and I actually need to wake up every night to press the button, so it will be, so we will see it every 24 hours. Yes, it's not a beer button, I'm sorry, it's not. So I need to wake up every night to press the button, so it will be roll up in 24 hours, because it has to be at night. Why? The CSV files are really, really big. And we can't put in during the day because the course teams are downloading CSV files as well. That's why we have no other options. So I'm really looking forward if someone can pull in time zone, so it won't be at night. So in the end, as I said, the Blender pulling out all the CSV files after analyzing the data and show it by a UI. So how the Blender looks? First of all, we wanted the Blender will focus on three things. A better visualization, as Avishai mentioned, the insight, it's not a good UX UI looking. Even though if you had something from, if you took the analyze from Raccoon Gang, it looks better than the insight of OpenEdX. The second one is the classroom status. The teachers will get immediately a classroom status to know, okay, well, how my class, where is it and how it's going, and call for action, which means a deep insight. So this is example in Hebrew, but still all of you know graphs and all of you know numbers, so you can just understand that by a quick looking, the teacher knows which of personal students to focus on and where all the class is in. Let me give you an example of an insight. So, for example, class insight, attention to a question. Question 4 has a significantly low average grade, but with high submission. If we take a look of a student, for example, the student Cristiano Ronaldo is constantly improving the last 5 units. So he's improving, he's in a good shape. And Anant, Ed, and Jenna got the highest grade in the unit chapter number 4. They are excellent students. Thank you, Ed. That's how the teacher knows which on the student to focus on, and it won't be by the last of the semester, it will be immediately. So as you see, we achieve a lot of goals. First of all, a data-driven decision. If sometimes, even not the teacher, it was the class the coach that has once in a while time taking download the CSV files and then start to spread it out to all the teachers now using it like Waze. They are every morning with the coffee break, they open the dashboard and looking for the Blender. And then they know, okay, with the Blender, I can make a quick decision by real data time. So they depend on it. And of course, to have a personal learning data, as you saw, to get a focus on the student that needs help.
Thank you. Okay, guys, so if so far, Avishai talked a little bit about the why, and Mirav talked about what happens today, we want to give you a short glimpse of the future, all right, and on what we are working now. And I want to relate also to what Anand says, which looks like a few years ago, but it was like, I don't know, yesterday, yes. And he wants to focus, and we are focusing actually on two things. First is hybrid learning. We want to focus on small groups, and we want to give data or provide more granular data about each one of the groups and about the learning that the students are doing. So let me show you how we are approaching it, and we need some friends. So you need to be our friends here. So till now, we've talked about Blender, right? So you saw Blender. Blender is an analytics tool for teachers, and now the teachers, in their small groups, can understand the performance of the learners. And we have some reports lab, some data science lab, We are having some visualization tools, which is great, but it's not enough, because the next step is to talk about personalized learning. And personalized learning, we want to understand two things. First of all, we want to understand what's the learner profile and how the learner really looks like. Because today we can understand only his final grade. The second part is that we want to understand the content profile. And actually we want to know what the content is actually teaching, not just content-wise, but also skill-wise. And we've talked with MIT guys about the metadata that we want to keep on each one of the content. And after we have these two phases, then we are going to our holy grail. And our holy grail is to build adaptive engines. And the adaptive engines connect the learner profile with the right content profile, and then the teacher is kind of a guidance, and it's like give him more tools. So we are never losing the teacher. And this is where we see the future, and I will show you what we are doing today to get like at least to the second phase. So let's talk about the second phase. The second phase is personalized learning, right? And we see here like 3 profiles. We have like Lisa and Maggie and Homer, and lucky enough, all 3 of them get 100% in the task that they've done, right? So all of them are great students, which maybe not, because if we are drilling down to the more granular data, we saw that Lisa succeeded in 2 attempts and solved the problem in 30 seconds. And we know that because we are tracking every event of her learning, and we saw that Maggie did it in 10 attempts, and it took her like 100 seconds, and she also used hint. And we saw Homer, which is weird, did it like in 1 attempt, and like he did it in 2 seconds with no hint, and we know him, right? So it doesn't sound so realistic. And then what happens is that we know that Lisa is kind of a talent, and Maggie is like the hard learner, and actually the cheater, which is Homer, is actually also thanks to MIT, because Giora Alexandron is like, and all the guys, I don't know like credits to everyone, just found that thanks to this granularity data, we can find also cheaters. And this is very interesting. So we want to deepen into the profiles, and for that, we know that we have many stakeholders. So we have government, we have like content developers, like Anoto, which left. LMSs, we have government, not left. And if we want to collaborate between all of them, we need some standards. So we've talked about LTI, and we are now using XAPI. And I want also to share a little bit about that. So, and this is something that is really happened thanks to the community. So XAPI is kind of a line, it's a log, just like 1 row, which says 5 things. Which student or who did, can you see this one? Yeah. Who did what, when, and in which result. So for example, Lisa answered attempt question 1, she got like 40, and it was now, right? So this is the XAPI, and what we've done, thanks to the community, is we've implemented it. Oops, actually it's here. We've implemented it, and we are saving all these events into a place called LRS, Learning Record Store. Okay, so it started back then in 2016. Ed and Nimisha, we had like a big conference in Boston, and Edley now took the opportunity and developed 1 warp of the tracking log, of the OpenEdX tracking log, and change them or transform them into XAPI. And I can just share with you from my experience, when I've done that in a previous organization, it cost us like thousands of shekels, all right? Like thousands of dollars, or hundreds of thousands of dollars. And now, thanks to the community, we've just got it for free. So that's great. And this is what we want to push more. And yeah, and then the idea here is to take the LMS, the data, the events, and keeps them in the LRS. And then actually, because it's an XAPI, everyone can develop and adaptive engines. And everyone can take this data and bring interesting insights and some interesting engines to improve the learning. And then we are complete the circle by providing adaptive experience directly to the X block in the Open edX environment. All right, so this is how it looks in the end. And if we will drill down to the adaptive engine, I can just give you an example how adaptive engine looks like. So this is what happens in the academy. So I hope we understand how XAPI looks like and what is XAPI. Based on this XAPI and the granularity of the data, we can extract some features. And features are interesting features, are more complicated than just like final grade. We have using hints or time per attempts, or we have the number of attempts at all. We have success in first attempt, so we will know what was the success rate of the task when the students just start work on it. And these features, which is again from the academy, are significant features that can predict learning. So we took them, and then with some machine learning stuff, which I love to get into, but we don't have time, is to, we can predict the behavior of the user, and we can define the user profile. And I just want to give you one example, and this is what we've done with creativity. So we've tried to predict the learner creativity. The bad news is that we didn't succeed, but no worries. And one of the things that we've done is try to predict the creative leap, like this moment where the user, when the learner knows that he can do like also red buttons and not just like blue buttons. So he's doing like blue buttons, blue buttons, blue buttons, and there is this moment. We've tried to predict this moment, and we found some interesting patterns where the time can help us to predict where the creative leap happens, but we didn't succeed. But I'm sure that others will, and this is why we are in the academy. So this is like the potential, right, of the XAPI and the adaptive engines, and how that can reflect back to the X blocks. And this is more technical, team. This is how we are implemented it in the architecture. So the idea here, and this is why it's in the near future, is that it is going to be implemented in Q2 or Q3. So it's not like long tail now, or we don't need to wait long to get it done. Yes, Merav? Hopefully Q2. And this is going to be in production with 700,000 users and many activities. And then we will start to analyze the data and get some very interesting insights. So I'll just recap. So I think that we want to focus on two things, on the small groups and on more granular data. The potential of granular data is huge, and it will help us also to improve the success of the learning in small groups. So Avishai.
Thank you, Roy. As you can see, it's a very fascinating evolution, because we started with the Blender, which is half manual, half automated. And now what Roy talked about, the adaptive learning tool, makes the automated part much more clever to enable the teacher to focus on what they need to do in order to do their most important thing in the world. So it's kind of evolution. The current status in Israel is that 700 teachers are using 10 MOOCs on edX, of course, and Campus AL, with 1,200 classes, and the grade value is huge. We just changed the behavior of the teacher. I can tell you that we got lots of calls for our support center, and they are shouting, why is it the data updated? And we're happy, because we changed the behavior of the teacher from downloading the data once a year to do it every day with the morning coffee. It's complete change, and the value is huge, because the teacher can enable the learners to encourage maybe the most important muscle in our times is the autonomous learner. I can, as a teacher, I can divide the class and to teach in a differential mode. This is really nice also, the dropout reduction. We have like in math classes in Israel, a dropout rate of 20% from the high level of mathematics to the lower. And in COVID-19, in this in the last year, the numbers were nearly 0%. And the reason is that I'm, as a teacher, I recognize a problem. If a student needs the help, I recognize it in November and not on March when everything, I can't do nothing with the student and it drop out. That's a great value also, shortening of learning time. A 30-hour course can be taken on, the learning effort can be like only 15. And it makes whole different world in the means of the experience of the class and the well-being, both of the teacher and of the students. And to sum up, it really redefined the role of the teacher as a researcher. So it's like I have 30 students at my class and I know how to give the right medicine for the right students or the right group. And we finally wanted to present you this final slide. And that's the great question. How can we cooperate and how can we work together? And I remind you this slide Roy presented earlier of Anant, talking about the one leg of edX and OpenEDX and the other of 2U with the DNA of a MOOC and the DNA of on-campus physical class face-to-face meetings, small groups. And would like to maybe to start the session of the Q&A with you, and I hope you find it interesting and excited as much as Meirav, Roy, me, and Eran Raviv.
So any questions?
Hello, thank you for the presentation. So the question I have is, you show with Blender there were some dashboards. So the question is, how was the process of defining which dashboards to show? You have 700 teachers with 10 courses that I believe they can have the same structure, but probably different disciplines, and maybe one is longer than the other one, shorter. So how was that process, and how did you reach these, let's say, 4 graphics that were there, at least in the screenshot? Thank you.
I can answer in a short answer that Blender was designed with this community of teachers, and you can drill down from a dashboard for the whole course, for one chapter, for one unit, for one component. So you can, it doesn't matter if it's a long MOOC or a short one, or the teacher can look at the outliers students or outliers components, or so it's very dynamic, the dashboard.
I just want to add that we choose several of teachers that they are higher than the other teachers. For example, in math, there is like someone that is in charge of all the teachers for the math. So with that woman, we work with and we talk to her, and she knew what the teachers want. That's how we collaborate with them.
I'll just mention that a few weeks ago I went to a fascinating meeting which called, this woman presented. She's a leading instructor in mathematics in Israel, and the title of the session was Mistakes of Blender. And one of the things that she said that Anat is one of my best students at class. She got 100, 100, 100, and suddenly 0. And she asked herself, how can it be? And the crowd suggesting answers, everything. And then she said that Anat was answering this chapter with her friend. They did it together. So it redefined the role of a teacher as a researcher. And you can participate and promote it in the community, etc.
Awesome. Any more questions? Nope. Cool. Okay. How many classes that your average teacher has? Because why I'm asking, you mentioned that there is a joke that Insights shows you like gender distribution for, and you know it for 35 students, but don't you know the progress of your 35 students, or how many students is per teacher in your case?
So on the maximum, we're talking about 200 students, but you ask about how many classes. The maximum is 2 classes per MOOC. So I can teach, I can use, you know, it's like a MOOC as a textbook. I can teach using 3 MOOCs, but the maximum classes for 1 MOOC is 2, what we do. And we have the problem of 1 to many and many to 1, because we have scenarios for unique teachers that want to teach more than that. And then we do we use cohort with CCX, with, it's like, you know, you're building a tent in a camping, so it's not so solid solution. And we understood that in talks here around that CCX is a very problematic feature, if you want to elaborate.
Yes, as I said. No, we heard that C6 is kind of end of life, and we really appreciate if it won't, because yeah, we really work hard on it, and we think he has a lot of potentials. Even though we need research and that someone you know, will take it with him and just add. Yes, there is a lot of potential in C6. So.
So I think there's a couple of things I'd say about that. One is I think there's broad agreement that the features of CCX are super useful and something that the platform benefits a ton from. I think there is a thought that if we can really get to the point where we've re-architected the storage of content to make it more flexible and reusable, and Daniel's been working a lot on that recently. I'm talking about block store and atomic learning units. Then CCX should be built on top of that. And I think it'll be a more sustainable and scalable architecture if we do that. But the feature set would actually be really interesting to know, like, your analysis in terms of which features are must-haves, which ones you never use, those sorts of questions.
Coming over. I just want to say great work and thank you for doing it. It's wonderful to see. And I'd say it's so important to keep going, because this is now like probably the penultimate use case that I've seen, even above the stuff that we did. And it's so fantastic to see, even with, say, bad tools or tools that are just okay, you're doing it, and there are people that want it. So keep going, and in the next year we'll be able to do, as Ed said, really think about how to re-architect that on top of Blockstore, and this will be the great motivation for that. So thank you again.
Awesome. Cool. Any other questions? We have some time still.
Guys, maybe I will talk about the 2 other points. So we've talked about the challenge with the CCX, but maybe you can share also your experience with the XAPI models, especially the academy, because like in 2016, we had all these universities, Berkeley, and like all guys that built kind of adaptive engines on top of XAPI. And I don't know if the engines are still there. I'm sure there are. And I'm sure that there are like some research around it. So if you have some thoughts on that, it would be great. And the third part is really, Ed, it's again for you. It's the metadata about the block, about the X blocks or the block store, because we want to extend the metadata there to have like, so we as a content developers can add more metadata, or the engines will decide about new metadata about each one of the blocks. So we will understand how does it help to for the learning. So yes, so the question is if like what's, yeah, Ed, welcome. You should stand with us, Ed, what are you doing there?
So an existing ticket on the roadmap related to atomic learning units where Braden is starting to do some substantial discovery around what the next phases of Blockstore could look like. So it sounds like you have some suggestions for things that you need around being able to add arbitrary metadata to blocks on the Blockstore so that you can use them for other purposes. Please go to that ticket and add that use case so that it can be in consideration for the next phase of work. To remember, the other question was, well, the work that Berkeley did, to my knowledge, was not based on XAPI. It was based on sending learner data via JavaScript API calls. It was very interesting, but at any rate, that's kind of immaterial. I'm not aware of anybody who is using, I wish Zia was here from Edley, using the new kind of adapted XAPI to do adaptive learning, but I'd love to see that happen. The whole point of it is to have a standard where people can innovate more without actually touching the core of the platform. And I think there's like a couple big thrusts for areas where I hope TCRL will invest over the next year. And one of them is atomic learning units. Another one of them is improving the analytics dramatically. And I think those two things kind of converge to allow us to approach adaptivity. Right now, it's really difficult, even if you got the information from XAPI to make adaptive recommendations. Being able to reach into a course and get a particular block and serve it to a learner would be difficult. So I think we have a bunch of root infrastructure architecture things that need to converge in order to achieve what we want.
One step at a time. Thank you, guys.